Okay, today's topic of discussion is regarding pH and drugs. Okay, pH and drugs. Mm, uh, this concept mainly disturbs us when we are dealing with two sections, absorption and excretion, right? Like acidic drugs are absorbed in acidic medium, acidic drugs are excreted in basic medium. So this is something controversial. So let's start from basic. Okay, what is the basic? um, all cells are covered by the lipid bilayer membrane, and whichever the drug uh, uh, whatever the drug that wants to cross this membrane, it has to be lipid soluble. And water lipid soluble drugs are the non-polar drugs. Non-polar drugs means uh, non-ionized, right? So non-ionized drugs are non-polar, so they are lipid soluble and they can cross the membrane, whereas ionized drugs are polar and they are water soluble. They cannot be absorbed. Since they are water soluble, they will be flushed away with water. This is the basic concept, right? Okay, let's remember this. Now I am going to give us very simple equation, which is Ha gives rise to H plus A minus. This is the very simple and basic equation. Here what is happening is an acid is giving rise to a proton and an anion, right? Or I can say uh, non-ionized form converted to ionized form, or another way we can say lipid soluble form converted to water soluble. Okay, this is the basic. Now what are we going to do is, let's we take a drug which is aspirin, and it is in the stomach. Okay, in order for aspirin to be absorbed, what has to be done? See, acid A for acidic. Aspirin is an acidic drug, so it is a simulated with Ha. Okay, uh, can gives rise to H plus A minus, right? A similar equation. Okay, in order for our aspirin to be absorbed, we need the compound to be in lipid soluble form, which is non-ionized form. That means we don't want the forward reaction, but we want a backward reaction, right? So we can do this by increasing the protons. If we increase the protons, the forward reaction will decrease and eventually the drug will stay in the its original form. Where will it happen? Increased protons are present in which medium? It is acidic medium, right? So aspirin in acidic medium stays in non-ionized form and thus gets absorbed in lipid soluble form into the systemic circulation. This is the concept one. It is regarding the absorption. Okay, next thing is excretion. Let us say this same aspirin, we have got this same aspirin, which is what is it, lipid soluble, we don't know anything. It is, let's say, just this is a Ha, and we want this drug to be excreted, right? So we want this drug to be excreted. What we know, in order to a drug to be excreted, it should be in water soluble form, that is it should be in ionized form. So we want the forward reaction to take place, right? In order that a forward reaction shall take place, what shall we do? We shall decrease the protons in that medium. Then automatically deficiency on this side, imbalance on this side will lead to increase in protons from increased sending of protons from this side, and will eventually balance this, right? So decreasing protons happens in basic medium. So what we want is we want this into be basic medium. Now in order to simplify this, absorption, if we want an acidic drug to be absorbed, it must be present in an acidic medium. If we want an basic drug to be absorbed, we want it to be in basic medium. If we want an acidic drug to be excreted, we want to be in basic medium, and a basic drug to be excreted, it shall be present in the acidic medium. Good.